So again, the same kind of process is happening in the notes right here. They start the first process by logging both sides because the exponential is a base 4. They put log base 4 on both sides. The only difference here is that once we do this simplification of those simplifying each other out, our exponent wasn't just an x, so our x is not yet by itself. We have to do one more thing to get that x by itself, and that's add 2 to both sides. So now we have just an added extra algebra step. So again, depending on which calculator you use, if you use the Desmos graphing calculator, then you can type, you can type that on the screen. Let me delete some of these so I can get to the top. You can type that in the calculator exactly like that. You would simply hit the function button, choose log base A, you'd do log base 4, and then inside the parentheses you would type 35.6 and then close the parentheses and then do plus 2. And you'll get a value of 4.577 if you're rounding to 3 decimal places, 4.577. Now, you can still do change of base. Just be sure you add the 2 to the end as they're doing in step number 3 right here. So you can still do change of base if you need to because you don't have access to the Desmos graphing calculator, and you'll get the same answer. So I'm going to go ahead and do this one with you, and then we'll pause the video and let you do these two, and then I'll let you check your answers. So I'm going to do log base 12 of 12 raised to the x plus 3, and that's going to be equal to log base 12 of 240. Now the log base 12 and the 12 simplified down to just x plus 3, and then this is a value that can be typed into a calculator. However, my x is not by itself, so I'm going to do one more thing to get the x by itself, and I'm going to subtract 3 from both sides. Do not think you can take the 3 away from the 240. That's not a 240. That's why it might be better for you to put that in parentheses. That's not 240. That's log base 12 of 240. So you cannot change that to log base 12 of 237. If you subtract 3 away from that, you have just messed the problem up. So this becomes log base 12 of 240. Then we're going to take 3 away from that value. Okay, that 240 right there is part of the log. So you can't take 3 away from it until you evaluate that log. So I'm now going to go to my calculator, and because I can, I'm going to choose the log base 12. I'm going to put the 240 in the parentheses, and then I'm going to close the parentheses, and I'm going to say minus 3. And my answer then is going to be negative 0.794, round to 3 decimal places, so 0.794. X is about negative 0.794. Go ahead and pause the video and see if you can work examples or try these B and C, and then start the video again and check your answer. Alright, so let's check your work. Yours doesn't have to be worked exactly like mine, but pretty close. There's not a lot of room for differences. I do want to point out that this was a sneaky trick on problem B right here. They gave us, anytime they give you an exponential, the exponential should be isolated on one side of the equal sign, so this part right here is not part of that exponential, so it needs to be moved first. So this is a little bit different. So I started off by subtracting 0.8 from both sides. Now that I have the exponential isolated on the left-hand side of the equal sign, I begin the process of getting rid of that base by logging both sides so it can cancel out or simplify out. Notice that I did go ahead and put the parentheses around the 4.9 because once those two simplify out and I'm left with the x plus 4, the next thing I'm going to do is subtract 4 from both sides, and I do not want you to take the 4 away from the 4.9. So this problem right here needs to be entered in the calculator. You can do it exactly the way it's written right here, or you can do the change of base, and you can do common log of 4.9 divided by the common log of 4.2, and then subtract 4 from that. Okay, I'm going to run to the Desmos calculator and just type in, oh, for Pete's sake, I'm just going to type in, let's move it over here. I'm going to do the log function and get the 4.2 at the bottom, and then inside the parentheses I'm going to put the 4.9. I'm going to close the parentheses, and then I'm going to say minus 4. And that gave me negative 2.892. Negative 2.892. On equation C here, the exponential was isolated. It was already all by itself, so I did the inverse of e, base e, which was natural log e. Those two are going to simplify out. Let me change colors so that you can see. That's the simplifying, and that leaves this side right here just to be 2x minus 4. Go ahead and put the parentheses around the 148 so you don't try to add that 4 to the 148. It just has to be added to the end. My x is still not by itself, so I continue doing inverse operations, and I divide both sides by 2. And then I'm going to go to the calculator, and I'm going to type in natural log. And you can go to the functions and select the natural log, but it's super easy to just type in natural log like that. So natural log parentheses 148. I don't know why it's natural log 148 plus 4. I don't know if when I hit the divide key, no, it's not. So I'm going to have to put parentheses around this so I can get, oops, that's a 9, not a parentheses. Parentheses, there we go. And now when I hit the divide key, it'll go down and let me divide by 2. So I've got the natural log of 148. I evaluate that, then I add 4, and then I divide everything by 2. So my final answer is 4.499. So 4.499 if I round to 3 decimal places. Next we're going to do solving log equations.